Okay, guys, so welcome. Section 10.8, it's about graphing linear inequalities. So let me start with definition. A linear inequality in one variable x is any inequality that can be written in the form ax plus b less than c, or ax plus b less than or equal c, or ax plus b greater than c, or ax plus b greater or equal c. Okay. Again, since we're talking about linear inequalities, we have to give the condition that a can't be equal 0, because when a is 0, you're just dealing with the numbers and you're comparing them. So let's review inequality symbols. Okay. So the first one is x less than a. So this symbol right here, we read less than. Okay, and the solution set includes the real numbers less than a but not equal to a. Next one, it's going to be x less than or equal to a. So we'll read that less than or equal. Excuse me. Less than equal. Okay, when you have less than equal, let me write this down because here it's important that we know. So the solution set, because the solution of inequality is not just one number, we're going to have many numbers. That's why we call the solution set here, includes the real numbers less than a, including a. Okay, so in previous, when we only have a less than, the solution set are all the real numbers less than a. So here the solution set are real numbers smaller, which is less than a. We're not including a. Okay, next one we have x greater than a. So this symbol right here we read as a greater than a. Okay, and the solution set are real numbers So the solution set for this one are real numbers greater than a, but not equal to a. So we're not including that number. And the last one is x greater or equal a. So we read that greater or equal. Okay. And the solution set includes the real numbers So the solution set includes the real numbers greater than a, greater or equal to a. Okay, so let's do the examples because I'm pretty sure that you guys, most of you feel very confident about that. So example, graph the solution sets. So we're going to graph them. First one, we have y is less than 0. So on the number line, which represents the real number system, I'm just going to put 0. This is the number which I have it. And the solution sets are all real numbers which are less than 0. And we're not including 0. So look what happened. Less than, okay? The direction of number line matching with the direction of your inequality, that means I need to shade everything to the left, okay? And we're not including 0. Let's do second example. You have x greater or equal -5/4. So this is how you're graphing. On the number line, I'm putting the number which you have on the right side. So again, I recommended that you keep variable on the left side, inequality symbol, and the number on the right side. So we have -5/4. Since you have an equal sign, so your solution set will include -5/4 as a solution. And now the solution set are all the numbers greater. So look what happened. The direction of inequality matching with the direction number lines, I'm shading everything to the right side, and greater or equal. That's why my circle next to the number -5/4, it's closed because we including 5/4. Okay, next one. 3. You may have to graph inequality, which is 5. It's greater or equal to a. What I recommended that you will rewrite it as a, and look what happened. If you read from right to left, so you will read that a is less than or equal to 5. They are equivalent, they mean the same thing. But I recommended that you keep your variable on the left side. So now to graph that, on the number line, you're going to put 5, the number which you have on the right side. Since we have an equal sign, so 5 is the part of the solution. And if you keep your variable on the left side, the way I'm teaching you to graph it, look what happened. Less than, the direction of inequality will match with the direction of the number line. So you will know that you have to shade it everything to the left. Okay? So I recommend it when you have inequality like in number 3, rewrite it. Put the variable on the left side, number on the right side, And again, we're not really switching inequality symbol, we're just rewriting. So if you read here from right to left, you have a less than or equal to 5, okay? So next, what we're going to talk about it's compound inequality. Compound inequality Compound inequality is a statement that involves more than one inequality. For example, you have -2 is less than x and x is less than 5. What that means, if you want to, this is compound inequality. Compound inequality. Because we have two inequality put it together. If you want to, this means you can break this down into two inequalities. That means that, and again, this is how I'm going to break it down. I'm going to rewrite only this part. Okay, so I have -2 is less than x, which again is the same, you guys know that already, as x greater than -2. I recommend it that way. And when you have compound inequality, you always have word and I will take care of this side of the inequality, and x is less than 5. So this compound inequality, -2 less than x less than 5, has the same meaning as x is greater than -2 and x is less than -5. So let me show you how you're going to graph it. So to graph the compound inequality, you're going to use one number line, okay, that represents the real numbers. And again, the number as long your inequality follows has this. Okay, the number which you have on the left side is -2. The number which you have on the right side it's 5. So that means the solutions are all the numbers between -2 and 5. Since you have strict inequalities, which means inequality without equal sign, we're not including -2 and and +5 as a solution. So this is the solution set. So that's what that means if you would like to graph it. The solutions are all the x's between -2 and 5. Okay, next. Okay, we're going to, I'm going to give you a lot of details in the sections. Next, I'm going to teach you how to write inequality using inequality symbol, how to graph it, how to write the inequality using interval notation, and set builder notation. Okay, so note, to represent the solution set of linear inequality, you can graph the solution set or use interval notation or use set builder notation. So it's very important that when you guys solving problems, you're paying attention to how they want you to express the solution of inequality. Okay. Okay. So let me create a table. So here I'm going to have inequality. Then I'm going to have graph. So show you how to graph it, each inequality. Then I will show you interval notation. And the last column will be set builder notation. Okay, so we have it. So the first one, inequality will be x greater equal a. So we already talked about it, how to graph it. We're graphing a, we're including a as a solution, and greater means that we're shading everything to the right side, because the inequality matching with the direction of number line. Okay, so we shade everything to the right side. Now, interval notation will be bracket a to positive infinity. So that bracket means that we including a, so all the numbers from a to positive infinity, including a. And set builder notation, parenthesis, I call them fancy parenthesis. The solution set are all the x's such that that line, straight line, you read it as such that x is greater or equal a. So this is set builder notation. Again, this straight line here, you read such that. So the solution set are all the x's such that x is greater than a. So this is set builder notation. Okay, next one. Next one will be x greater than a. So to graph that, you're putting a on the number line. In this case, we're not including a, so you keep open circle. Greater, the inequality match with the direction on the number line, so you're shading everything to the right. Interval notation will be, if you're not including a, you're going to put parenthesis, a, comma, infinity. When you have infinity, you always keep parenthesis, okay? And set builder notation will be, the solutions are all the x's such that x is greater than a. So this is set builder notation. Okay. Next one, let's talk about x less than equal a. So we graphed that before. So you're putting a on the number line. You have equal sign, so we're including a. Less than, the direction of inequality match with the direction of the number line. So you're shading everything to the left. Okay, the interval notation will be, in this case, from negative infinity to a. And we including a, so you keep it bracket. So when you include the number, you keep it bracket. And set builder notation, the solution set are all the x's such that, and you just copy your original inequality. X is less than equal a. Okay, moving on. So I'm showing you all the possibilities. I think that will help if you didn't see inequalities for a long time. Next one is x less than a. The way to graph it, you're putting a on the number line. We're not including a, so keep it open circle, less than, so inequality match with the direction of the number line, so shade everything to the left. Interval notation will be from negative infinity to a. Since you're not including a, keep parenthesis, and set builder notation. The solution set are all the x's such that x is less than a. So this is set builder notation. Okay. Next, here I'm going to talk about compound inequalities. So next I'm going to focus here on compound inequalities. I'm going to show you all the possibilities of how to graph them, how to write the interval notation, and also set builder notation. So first one will be x, it's greater than a, and x is less than b. So to graph that, on the number line, you're going to put two numbers, a and b. Since you only have inequality, so you keep open circles and you're shading everything between. So that's the solution set. This is graph notation. The interval notation will be parentheses AB. So all the numbers from A and B. And set builder notation is technically you're going to rewrite it. The solution sets are all the x's such that, and you're just going to copy that inequality. A it's less than x and x is less than b. So that's the set builder notation. Okay, next it's going to be x, which is greater or equal a and less than equal b. So this is how you graph it. Very similar like previous, you're putting a and b on the number line. However, in this case we have equal signs, so we're including a and b as a solution and all the numbers between. So in this case, the interval notation is going to be bracket from a to b, okay? So we including a and b, that's why you have a and b in a bracket. And set builder notation, the solution set are all the x's such that, and I just copy the inequality. A is less than equal x, x is less than equal b. Okay, continue. Next, you're going to have x greater or equal a, but on the right side you have only x less than b. So we're mixing greater strict inequality with regular inequality. So to graph that, you're putting a and b on the number line. Look what happened here when we have x, it's greater or equal a if you read from right to left. So when you have a, you're going to keep it closed circle. Now on the left side, on the right side of inequality, you have x less than b. So here we have strict inequality. So where you have a b, you're only going to keep open circle and you will shade everything between. So interval notation will be bracket a comma b parenthesis, because a it's part of the solution, however b is not part of the solution because we have open circle. And set builder notation, you will just put the same thing. The solution set are all the x's such that, and just copy inequality. A less than equal x, but x is less than b. I forgot to close it over there. Okay, and we have two more. We have last one, I think. X is greater than A, however, is less than equal B. Okay, so to graph it, we're going to put A and B on the number line. In this case, A has an open circle, B has a closed circle, and you're shading everything between. So interval notation will be parenthesis A comma B bracket because we're including B in this case. And set builder notation, it's going to be all the x's such that, and just copy inequality. A less than x, x is less than or equal b. Okay. So this is how you're writing the solution set using the graph, interval notation, and set builder notation. I think it's time to start practicing. So let's practice. Okay, let's practice. Express each of the following in set builder notation and interval notation. Okay, so the first one, this is what I'm giving you. I'm giving you the graph. We have -2, open circle, and I'm shading everything to the right. So you need to express the solution using interval notation. So interval notation will be, and again, this is this case right here, right? But we have -2. Okay, so interval notation will be -2 comma positive infinity because we're not including -2. Set builder notation is the solution set are all the x's such that, and x is greater than -2. So again, I'm going back to the table. We have this case. Okay, so your a is equal to -2. Okay, next one. Let's practice more. Now I'm giving you inequality. X is less than 3/2. So I want you to write the interval notation. Okay, so we have x less than 3/2. So we have this case right here, x less than a. So interval notation will be from -infinity to a. In our case, will be from -infinity to 3/2. Set builder notation. So all the x's such that x is less than 3/2. Okay. Let's do number 3. So I'm giving you the graph. We have, excuse me, we have -3, open circle. We have -1, close circle. And I'm shading all the numbers between. So when you have two numbers, you guys know that you're dealing with compound inequality. So I want you to write the interval notation. So interval notation, again, this is what we have. Open, close. So this is our compound inequality. So this is our example right here, the last one. So we're going to have the interval notation will be -3 to -1 bracket. Okay. Now set builder notation. Okay, you can use the help of the chart which I gave you, but the solution set are all the x's such that, and we have x is greater than -3, however, less than equal -1. So again, this is this example. Okay, the last one. Okay, maybe one more, and I think we're good to go. So I will give you one more. You have compound inequality x is greater than -4, less than 0. So we need to write the interval notation. So that will be parenthesis -4 comma 0 because we're not including those numbers. This is this one right here. The first compound inequality which I gave you guys. Okay. Okay. So now we need to write the set builder notation. So all the x's such that x is greater than a, less than b. So in our case will be set builder notation is all the x's such that, and you just copy that inequality. -4 is less than x and x is less than 0. Okay, so we practice writing interval notation, set builder notation, and let's talk about addition and subtraction properties of inequalities next. Okay, so next what I'm going to focus on addition and subtraction. Properties of inequality. Okay, so this is what we learning. Okay, so let me just write a note for you. You can add or subtract the same number to both sides of inequality by keeping the same inequality symbol. So when you solve inequalities like equations. You isolate the variable, you keep variable on the left side, inequality and the numbers on the right side. So you can add and subtract the same numbers, any numbers to the inequality. And when you do that, you're always keeping the same inequality symbol. We not reverse anything. So let me give you an example. X less than 7. What I can do, I can add 5 to both sides. As long I do that to both sides of inequality, so I have x plus 5. And like you guys see, I keep the same inequality symbol. 7 plus 5. Okay, so that will be x plus 5 is less than 12. Okay, so this inequality is equivalent to the first inequality. Okay, And when you subtract, it will be the same thing. Or less than 7, and if you want to subtract 5, so I'm going to subtract 5 from both sides. So we will end up with x minus 5 is less than 7 minus 5, which after simplifying that give you x minus 5 is less than 2. Okay, so this inequality, it's equivalent to this inequality, which means have the same solution. Now, there is different rule about multiplication. So multiplication and division. Properties. Okay, for inequalities, of course. Okay, you can multiply. So let me write note for you. You can multiply or divide both sides of inequality by the same number by following. Okay, and this is what you're going to follow. Okay, first one. If you multiply or divide by positive number, okay, keep the original inequality. And the second one, if you multiply or divide by negative number, okay, what you're going to do here, you're going to reverse the inequality symbol. So that means less than become greater than, or greater than equal will become less than equal. Okay. So let's do the examples with multiplication and division. Let's practice that. So let's say you have to solve an inequality like this. 2x is less than 4. So to solve that inequality, you need to isolate x. So what we'll need to do, we'll need to divide both sides by 2. So I'm dividing both sides by 2, and we end up with x less than 2. Since I divide by positive number, I didn't change inequality. I kept the same inequality symbol. Okay, but if you will have example like this, negative 1/2 x is greater than 3. Okay, so what I will need to do here, I will need to isolate x. I will need to divide both sides by negative number, which is negative 1/2. So I'm going to divide both sides by negative 1/2. And what happened here, since we're dividing by negative number, this inequality will reverse, which means greater will become less than. And then we have 3 divided by negative 1/2. So the shortcut is keep, change, flip. Keep 3. When you divide by fraction, that division change to multiplication. Flip means you multiply by reciprocal of negative 1/2, which is negative 2/1. And we have x less than negative 6. Okay, and that's the solution. So we only reverse inequality symbol, and that's the only one time, only when you multiply or divide inequality by a negative number. Other than that, you keep original inequality. So let me give you the hints for solving linear inequalities. I will give you some steps. Steps for solving linear inequalities. Okay. So you solving linear inequalities the same way like you solving linear equations. Okay. So first, what you're going to do, you're going to simplify both sides of inequality. Remove parentheses, combine like terms. Second, what you're going to do, you're going to add or subtract the same number from both sides. From both sides. To isolate the variable. Of course, if you have variables on two different sides of inequality, you want to bring them to the left side. Third will be divide both sides of inequality by the coefficient of the variable. And of course, remember to reverse the sign if the coefficient is negative. So that's the only way. That's the only time when we reverse inequality. Okay, and let's practice. So that's 3 steps. So we're going to practice. So example, solve each inequality and graph the solution set. Express the answer in interval notation. Okay, so let's do the first one. We have 2y minus 5 less than y minus 11. So first thing what you want to do here, you want to bring y to the left side. And you're doing that like with the equations. Since you have positive y, you're going to subtract y from both sides. So we have 1y minus 5 less than negative 11. We keep the same inequality symbol. Next, what you're going to do, we need to bring negative 5 to the other side of inequality. So just add 5 to both sides. And that will give you y less than negative 11 plus 5. That will give you negative 6. Like you see, all the time I keep the same inequality because I'm only adding or subtracting numbers. And we have it. This is the solution. We have variable on the left side, inequality, and the number on the right side. So we need to graph it. So graph the solution set. So number line. On the number line, I'm going to put negative 6. Since I have strict inequality, it's open circle. My inequality match with the direction of the number line, so I'm shading everything to the left. Okay, and interval notation. Will be from negative infinity to negative 6 parenthesis. Okay, let's do second example. We have negative 5x plus 2 greater equal 22. So I need to only keep variable on the left side. So positive 2 has to be moved to the right side of inequality. Since it's positive 2, you subtract 2 from both sides. And we have negative 5x greater equal 20. And now what we're going to do, we need to divide both sides of inequality by negative 5. So that will cancel and we end up with x. Since we're dividing by negative number, you need to reverse inequality symbol. So greater equal will become less than or equal. And 20 divided by negative 5, it's negative 4. Okay, so we have it. Now we're going to graph the solution set. So number line, we're putting negative 4 on the number line. Since we have equal signs, so I'm going to keep it circle close. Less than the direction of inequality match with the direction of the number line, so I'm shading everything to the left. Okay, and interval notation is from negative infinity to negative 4 bracket because we're including that negative 4. Okay. Okay, I know it's a long lecture. Next, what we're going to do, we're going to solve two compound inequalities. Okay, so next I'm going to focus on solving compound inequalities. Compound inequalities. Okay, that's the one which have two inequalities put together. Okay, so let's focus. Let's do the example. So example 1, you have negative 3 less than equal 2x plus 1 less than 7. So how you solve inequalities like that? Let me give you a hint. So the hint is to isolate the variable in the middle. So you want to have something like this. number less than or less than equal x less than n number. Okay, that's what you want to have. And of course, you may have a less than or greater than or less than equal. Okay, so this is what we want to have. Okay, and in this case, the operation performed on the middle the operations perform on the middle portion of the inequality must also be performed on the left hand side and right hand side. Okay, so this is what we're going to do. Okay, look what happened. The idea is, in this example, to have only x in the middle. So first what I need to do, I need to move that 1. So I need to move that 1. Okay, so in order to isolate the variable in the middle, I need to use the opposite of 1. So I'm going to subtract 1 from the middle, from the right side, and from the left side. So you're doing that operation 3 times. And now we're going to simplify. -3 minus 1, that will give you -4. We keep the same inequality, less than equal. +1, -1 cancel, so we only have 2x in the middle. Less than 7 minus 1, that gives you 6. So we subtract numbers 3 times, from the middle, from the right, from the left side. Now the idea is to isolate x. So to isolate x, I have 2 times x, so I need to do the opposite operation of multiplication, which means I'm going to divide middle by 2 to get up by itself, and I need to do the same operation on the right side of the inequality and the same operation on the left side of the inequality. So we have -4 divided by 2, which is -2, less than equal x less than 6 divided by 2, which is 3. And this is our solution, okay? So this is our solution. So now we have to graph it. So the graph looks that way. Number line, we put in 2 numbers. The first one it's -2, the second one it's 3. So next to -2 you have also equal sign. So we're including -2 as a solution. 3, again, that's only strict inequality, so we're not including that solution. And you're shading everything between -2 and 3, including -2. Okay? And interval notation, will be bracket -2 comma 3 parenthesis. So let's do one more. With compound inequalities, we have -3 less than equal -5 plus 2y less than 11. So the same thing, the idea is to get only variable in the middle. So I need to do something with that -5. So I really want to get rid of -5, so we're going to use the opposite. I'm going to add 5 to the middle, 5 to the left side, and 5 to the right side. So that will cancel, and we'll end up with -3 plus 5, which is 2. Copy inequality. In the middle, we have 2y, and on the right side, we have 11 plus 5, which is 16. And to be able to isolate y, you see that we have multiplication 2 times y, so we need to now divide both sides of the inequality, the middle by 2, right side by 2, and the left side by 2. So we have 1 less than equal y less than 8. So this is your solution. And with inequalities, most of the time they're going to ask you to graph it, graph the solution set. So I'm putting two numbers on the number line, 1 and 8. Next to 1, I have inequality with equal signs, so you're going to keep it close. Next to 8, you only have inequality, keep that circle open, and shade everything in the middle. So this is graph, and interval notation will be bracket 1 comma 8 parenthesis. Okay. Couple more problems. I'm going to teach you how to translate expressions involving inequalities, and then we will be done with this section. Okay. So a little more. So this is the last part of section 10.8. Next, what we're going to focus on, we're going to focus on translating expressions involving inequalities. So similar to what we did when we translate expressions into equations. So I will just give you keywords with inequalities, so that will help. Of course, less than. So A is less than B. That means that A is less than B. Okay. What else you can have it? Of course, you can have A it's greater than B. Which means A it's greater than B, but also you may see when we talk about greater, you may see that something like this, A exceeds B. So greater than is the same as exceeds. So we're graphing that the same way. Okay, just also create keywords. Here you guys going to have math inequality. So on the right side of the table, you have inequality. On the left side, you have keywords. Next one, of keywords, you have, we can have A is less than or equal to B, which is the same. So this one has the same meaning as A is at most B, or this is the same as A is no more than B. Okay, so less than or equal is the same as A is at most or A is no more than. Okay, so that can be new. And the inequality which we're going to use, it's A less than equal B. One more keyword. A is greater than or equal to B. So of course we're graphing this way. So the keywords to this one will be A is at least B, or if we're talking about A is greater than or equal to B, sometimes we're saying that A is no less than. No less than B. Okay, so all of them have the same meaning. Greater or equal means A is at least B, or A is no less than. Okay, and all of them have the meaning of greater or equal. So let's just practice that. So we're going to do the example. Translate each phrase to mathematical inequality. Okay, so the first one will be Bill needs a score of at least 92 on the final exam. Okay, so how are we going to translate that into mathematics, mathematical expression? So x, so here will be the solution. So let x represent Bill's score. From final. So Bill needs a score at least 92. Okay, so how are we going to translate that? This one will just going to be that x at least means greater or equal. So x greater or equal 92. Okay. Second, fewer, I'm sorry, fewer than 19 cars are in the parking lot. Okay. So let's write the solution. So what I'm going to do, I'm going to represent C, will represent the numbers of cars. Okay. So fewer than 19, did I put that? Fever actually will be here. Okay, so that means less than. C is less than 19. I forgot about this one. Fever means less than. Okay, so you guys can add that. That means less than. Just less than, sorry. And number 3. The heights age of women who wear petite size clothing are typically between 58-inch and 63-inch inclusive. So we need to translate that. So again, age is the height. So now we're talking about the women who were petite size, and we're telling that they are between 58 and 63 inches. Between means that you have compound inequality, okay? But we also talking about word inclusive, so we including, so starting from 58 inches exactly, finish on 63 inches exactly. So that means we'll have the equal sign also. So it's between 58 and 63, including 58 inches and 63 inches. Okay? And one more word problem. I know it's a lot, but I want to do one more word problem, which we did very similar with equations. Solve the word problem using inequalities. So, example, to get at least B, and this problem should be familiar to you guys. In maths, Simon must average at least 80 on all tests. Suppose Simon has score 60, 72, 98, 85 on the first four tests. Determine the minimum score he needs on the fifth test to receive B. Okay, so what we need to know, we know that to get B in the math class, Simon needs the average of 80, at least 80, okay? So 80 and above. Because 80, like here in our college, is from 80 up to 89, right? So he already took four tests. He got 60, 72, 98, 85. And the question is what he has to get from the fifth test, which we may think like final test, to get that 80. So to reach that at least 80, okay? And to get B, to receive B. So let's introduce the verbal. So X, it's going to be the score from the fifth test. So what he has to do, so let's explain that to get B, the average from all 5 tests has to be at least 80. Okay, so first we need to find the average. So to find the average, we already have 4 tests. So we have 60 plus 72 plus 98 plus 85 plus test number 5, which is X. And to find the average, we're going to divide all of them by 5 because we have 5 tests. And to get B in the class, he needs to have at least 80. At least 80 means he has to get greater or equal to 80. So again, at least 80, going back to our table, at least B, A is at least B, that's your greater or equal sign. And now we're just going to solve the inequality. So what you want to do first here, you want to multiply both sides by 5. So you don't have a fraction. So I'm going to multiply both sides by 5. Let's keep that in parentheses. So this one cancel. And let's, if you will add all those numbers together, we have 60 plus 72 plus 98 plus 85. So we're getting 315 plus X is greater than equal 400. Okay, now let's subtract 315 from both sides. And that will give us that X is greater than equal, and we have 400 minus 315, which is 85. Okay, so what that means, from the fifth test, he has to get minimum of 85 to get B from this class. So answer is Simon needs at least, which means minimum also, his minimum test score, at least 85 to get B from math class. Okay, guys, so that's it. It was long section 10.8, a lot of information, but here you go, you have all of them. So I'm going to post that lecture for you on Canvas.